All right, hello everybody. We've got a request for this question, section 5.5, number 5a. Prove that if 151 integers are selected from the numbers 1 through 300, then the selection must include two integers x and y, where x divides y, or y divides x. Okay. Now the trick to this proof involves the how many powers of 2 are in each number, or more specifically, whether the number is even or not, and how even it is, like how many multiples of 2 are in it. Let's deal with that. What should I write here? So I'm going to create a set for every I from 1 to 300, where I is odd. Let SI be the set 2 to the k times I, such that k is in Z, k greater than or equal to 0.
Hey everybody, let's take a break from the example for a sec. The example I'm doing here is really just a single example, and there are literally infinitely more problems you can run into on a discrete math exam. And odds are good you'll run into problems you've never seen before and be expected to apply what you know to solving them. But if you don't understand the content, you have no hope. So if you're taking a university, if you're a student taking a university discrete math course, and you're serious about not just getting a good grade, of course, yes, getting a good grade, but if you're serious about understanding the content, then go ahead and click the first link in the description down below and book a free call with me. Now, back to the example.
Okay, so SI is the set of all numbers where it's the odd multiple. Is that what I want? Yeah. That the number itself is a power of 2 times that odd number. So let's just pick some random numbers. I mean, if I pick 23, 23 is prime. And so 23 is in the set S23 because that's 23 times 2 to the 0. Okay. If I pick 4, well, 4 is in the set 2 squared times 1. So it's in the set S1. So S1 is the set of all powers of 2. 8 is also in there because it's 2 cubed times 1. What else? How about 11? 11 is prime. That's easy. How about 15? Where's 15? Well, 15 is 2 to the power of something times an odd number. What is it? Well, it's 2 to the power of 0. There's no 2's in 15. So times the I then is 15. So 15 is in S15, right? What's another example? Let's pick one with a couple powers of 2. How about 24? 24 has got a power of 2 in it, right? So 24 has an 8 in it. So it has 3 2's in it, 2 to the power of 3 times 3. 8 times 3 is 24. And so the number 24 is in S3. So what I've done here is I've partitioned all the integers into what is their odd factor.
Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
Okay, every number has an odd factor, whether that number be a 1, if the number is the power of 2, or take out all the powers of 2, and whatever's left, that's your odd factor. Okay, that's the trick to this question. What do I want to say now? Every number from 1 to 300, for every x in the set 1 to 300, there exists a unique I in 1 to 300 I odd such that X is in SI. Okay, so how many SIs are there? There are, well, 1 to 300, there's 150 odd numbers. Yeah, there are 150 different such sets. Thus, by the pigeonhole principle, if 151 numbers are chosen, there must exist some I, I'll maybe call it I0 as a fixed number, 1 to 300, I0 odd, such that two of the numbers, such that at least two end up in SI0. Say, the first one we'll say is 2 to the power of K1 I0 and 2 to the power of K2 times I0. That's the key. So now I've got two numbers inside that particular set, SI0. And they both have the same odd factor, and they have different powers of 2. Well, one of the powers of 2 is smaller. That one will divide the other one. We're done. If K1 is less than K2, then 2 to the K1 I0 divides 2 to the K2 I0. And otherwise, K2 is less than K1, and then 2 to the K2 I0 divides 2 to the K1 I0, and we're done. Okay, so that's the trick there, is pulling out the powers of 2. So hope you found that helpful.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.